Hi, in this video I'll show you another example of doing stoichiometry while dealing with limiting reactants. So we have when sodium hydroxide reacts with sulfuric acid, water and sodium sulfate are the products. So let's write that down. Sodium hydroxide is NaOH. Reacts with sulfuric acid. Sulfuric acid is H. Sulfuric becomes 8. Sulfate is SO4 2 minus, so H2SO4 yields water H2O and sodium sulfate Na2SO4 SO4 2 minus Na2 2 plus. So let's see here. NaOH, we don't know how to find that yet. H2SO4, we don't know how to find that yet. H2O is liquid, and that's all we know. So let's balance this first. 2 Na on this side, so this has to be a 2. OH 2O 1H. This has 2H1O on this side, 2H1O on this side, plus an additional H2 and SO4. 1 SO4, that's balanced. 2 more H, so this has to be a 2. Let's see, 2H, 4H, 4H, 2O, 2O. Okay, everything's balanced now. Okay, now first things first, we have 15.5 grams of sodium hydroxide, NaOH. Like converting to moles. 1 mole of NaOH. Na is 22.99 plus O is 16 plus H is 1.01. We have 40. 15.5 divided by 40 is 0.3875 moles of NaOH. In the balance equation, we have 2, so we have to divide this by 2, which gives us an answer of 0.19375. Now let's see. I forgot to type out the problem. Whoops. A reactant with 46.7 grams of sulfuric acid. That's a full problem. Okay, back to where we are. Now, I was about to say, because it only gave us one reactant. When it only gave us one reactant, there will be no limiting reactants. So now when it gave us two reactants, there's a high chance that one of them is limiting. So let's see. 46.7 grams of sulfuric acid, which is H2SO4. H2SO4. 1 mole of H2SO4 is 1.01 times 2 plus S, which is 32.07 plus O, which is 16 times 4. We get 98.09. Divide these two, 46.7 divided by 98.09. We get 0.476093. Sulfuric acid is H2SO4, and it does not have a coefficient, so it's basically divided by 1, which is the same thing. Out of these two, this one's a smaller number, so we're gonna keep in mind that NaOH is a limiting reactant. Let's write everything again. 2 NaOH plus H2SO4. 2 H2OL plus NaSO4. Alright, now that we figure out that this NaOH is a limiting reactant, we do not need to use it again. Do not write these two numbers in the reaction before, after, before, change, and after. Change, after. You will not use these numbers in the before section. You will only use what you're given in the problem. It gave us 15.5 grams of sodium hydroxide and 46.7 grams of sulfuric acid. Sodium hydroxide, and we know that sodium hydroxide is a limiting reactant, so we're going to start with that first. 15.5 grams of NaOH. We use moles. The most we have is this one. Do not use this one. Use this one. Do not use the one that you get after divided by 2. 0.3875 Okay, change after it has to be 0 since it's limiting reactant. This is what gets used up first. Limiting reactant is basically what gets used up first. Now this gets used up first, so the limiting reactant has to equal to 0. Now these two have to start with 0. Since this is the excess reactant, as this is now the limiting reactant, that means after the reaction, there'll be some extra of this left over that cannot form a reaction because there's not enough NaOH. The change has to be 2/2. Remember, this has to equal to 1 in order to, when you subtract it, equals to 0. Okay, now what we're looking for is calculate the weight of sodium sulfate. Sodium sulfate is NaSO4 2. So we start off with 0. Coefficient is 1 plus. Forgot the minus. Plus. Reactants is minus. Products is plus. 1, I got it from here. 1 NaSO4, and the 2 I got it from here, of what we're comparing with, comparing what we have. So 2. Since it did not ask for the excess reactant, which is our H2SO4 here, we can basically skip this. We will not use this number, and we can skip this 2 since they didn't ask for it. So we have 1/2 over here times, always the same number of 0.3874, 0.3875. Now basically 0.3875 divided by 2, and where we found is going to be the same number as over here. So this is going to equal to 0.19375. As you can see, I already did 0.3875 divided by 2 over here to find out the limiting reactant. So I don't need to plug into my calculator and do the process again. I already have this as my answer. So now with that as our answer, 0.19375 moles of NaSO4. 1 mole has Na, which is 22.99, plus S, which is 32.07, plus O, which is 16, plus 40, isn't it? Times 4. Oh no, this time it's NaSO4, not NaOH. Okay, so 21.99 plus 32.04 plus 16. So I get 119.606 grams. And if over here it says 2 NaSO4 2, you have to multiply everything in here by 2. Everything is dependent on the number of moles you have. So over here we only have 1 mole, so just Na plus S plus 4 oxygens. Let me double check my work. Na is 22.99 plus S, which is 32.07 plus 4 oxygens. We got 119.06. Okay, now 0.19375 moles of NaSO4 multiplied by 119.06 grams. We get 23.067875 grams of NaSO4. Now, round to significant digits. 3 significant digits, 3 significant digits. Our answer will be 3 significant digits. 23.1 grams of NaSO4 will be created if we have 15.5 grams of sodium hydroxide reacting with 46.7 grams of sulfuric acid. Thank you for watching.